Alright, welcome to another class with Mathemasoft, and this is a new topic and I'm so excited to be introducing this topic, and that is surds. Okay, so we want to introduce surds as a new topic in this video. So uh, to understand what surds is in maths, we need to actually understand some numbers here. These two numbers that we need to actually understand what they are actually called rational number and irrational number. Okay, so anything surd, is actually based on the knowledge of these two. So what are rational numbers, or what is a rational number? If we have a number, okay, we have a number that we can express as ratio or as a ratio of two integers. Okay, so if you have a number that can be expressed, okay, as a ratio, I do hope you know what a ratio is, as a ratio of two integers. Okay, let's call the integers let's say p over q. Okay, if we have a number that can be expressed as a ratio of two integers, and in this case we should note that such that q is not equals to 0. Of course, q shouldn't be equals to 0 here. If not, we are going to have an undefined fraction. Okay, so such that q is not equals to 0. So we say such a number is referred to as a rational number. Okay, rational number. So if we have a number that can be expressed as a ratio of two integers, okay, we are just using an example of two integers. Let's say the integers are actually p and q. So in other words, if we have a number that can be expressed as a ratio of p to q, or as a fraction p over q, such that q is not equals to 0, we say such a number is called rational number. So what is a rational number now? A rational number is a number that can be expressed as a ratio of two integers, such that the denominator is not equals to 0. In fact, if you really want to understand the why we call it rational number, the word rational, okay, rational is actually from the word ratio. Okay, and you can practically see that. So rational is from the word ratio. So when we say a number is rational, it means that it can be expressed as a ratio of two integers. Okay, so any number that can be expressed as a ratio of two integers, denominator not equals to 0, such a number is called a rational number. Now let's take from example. What are the examples of rational number? If you look at 3 is a rational number because 3 can be expressed as a ratio of two integers. That's 3:1, which will definitely still give you your 3 back. Another example is that of another rational number is we can also use 4.5. 4.5 simply means 4.5, which will give me 9/2. So 4.5 can be expressed as a ratio of 9 to 2, or can be expressed as 9/2. So we say 4.5 is a rational number. So this, is what you need to know about rational number. So irrational number, just the way it sounds, okay, it's just the opposite of rational. Irrational number. Since irrational number is a number that can be expressed as a ratio of two integers, okay, then we say irrational number or an irrational number. Let me so that I can use the okay. An irrational number is a number, okay, that cannot be expressed, okay, as a ratio of two integers rather, two integers p over q. P over q is just an example, such that q is not equals to 0. So an irrational number is a number that cannot be expressed as a ratio of two integers. For example, p over q, such that what q not equals to what 0. Okay, so it simply means that these are kind of numbers that it's quite impossible for us to get their exact values. In most cases, we only use their estimated values. Okay, take for instance, the first one you will encounter is actually root 2. Okay, root 2 cannot be expressed as in form of p over q or as a ratio of two integers. Okay, if you try this, just try this on your calculator. That's a root 2. You'll see that it will give you almost like an endless numbers after the decimal points. It will only stop at that because your calculator has been calibrated or has been programmed to contain a limited digit of number. If you put root 2 in your computer, okay, you will definitely see that you would have numbers after the decimal point more than that you have when you did it on your calculator. So root 2 is an example of such number. Okay, in fact, I can actually tell you that the root of the square root of prime numbers. What are prime numbers? Prime numbers are numbers that can only be divided by 1 and itself only. Okay, so prime numbers, the square root of prime numbers, okay, they will all result to being a rational number. Look at your root 3, look at root 5, okay, look at root 7, and so on and so forth. These are irrational numbers. We also have some some constants, okay, like your pi. Okay, so an example is also your pi. We usually use 3.142. This is just an estimated value. It's just an estimated value of pi. It's not that pi is exactly 3.142. okay, so it's just an estimated value. So pi in itself is also an irrational it is an irrational number. Okay, so this is what we have as introduction to surds, understanding rational number and irrational number. So what is now surd? So surd, okay, is these irrational numbers which are actually square roots, or which are roots of rational numbers. They are the one we refer to as surds. So the irrational number, okay, these irrational numbers, irrational numbers are referred, okay, to as surds. So these irrational numbers are the one that we actually refer to as what? Surds. So surd has to do with, dealing with expressions, equations, where we have irrational numbers. Okay, and in surds, we will definitely perform, the normal arithmetic that we normally do in math, such as we are going to look at addition. In fact, before that, we are going to look at a simplification of surds. Okay, simplification. Okay, we are going to look at addition. Okay, subtraction. Okay, multiplication, and division. Okay, basically we are going to do this. So how do we, simplify irrational numbers or expressions that have been given in irrational numbers? How do we add them? How do we subtract them? How do we multiply? How do we divide? We are going to look at all these in the course of this topic, source. So for now, that's the introduction, and see you in the next video. We'll be getting to the real work. Thank you.